The next speaker is Evgeniia Golovina, and you're working for a company, is it Do It Now, NZ. So we're going to hear about EESSI, install once, run anywhere, collaborate everywhere.
Yep. Thank you. So hi everyone. Today I would like to talk about EESSI. It's a unified, portable, reproducible, architecture optimized software framework delivered at global scale. But first, let me tell you a little bit about our company. So we are independent and partner agnostic team focused on delivering reliable HPC and AI services. We operate globally with offices in Europe and New Zealand. We deliver 24/7 support to make sure that your HPC and AI workloads running worldwide. So we accelerate scientific discovery, product development, and AI innovation. We design, deploy, and maintain HPC systems so that our clients can focus on research, innovation, and results, not complexity. So we work with more than 200 clients across different industry sectors, for example, aerospace, pharma, energy, life sciences, and many more. So every year we support more than 20,000 users, build around 150 clusters, and deliver more than 200 training sessions. So our HPC and AI services cover system installation, support, R&D, and expert consultation and training. At Do It Now, we also contribute to the global HPC community. So for example, we are active partners and contributors to EESSI Build. We also work with Open On Demand and also contribute to diversity and inclusion initiatives such as Women in High Performance Computing. So now let's talk about EESSI and why it exists. So scientific computing has changed dramatically over the last few years. The number of available scientific software applications has exploded, and the software ecosystem is changing rapidly. At the same time, HPC systems getting more diverse. Cloud computing is becoming a part of everyday scientific workflow. For the HPC, so software stacks are also getting more complex. Dependencies are harder to manage. And both system administrators and users are under growing pressure to keep the systems working, reliable, and performance optimized. So all this comes with a cost. So first of all, we are no longer ensured that reproducibility across different systems. Second, the binary compatibility across architectures is no longer guaranteed. Third, software installation and rebuild times are getting longer. For HPC centers, this translates into ongoing and heavy maintenance burden. This burden gets even heavier when we talk about supporting emerging workloads such as AI pipelines and data-intensive applications. So EESSI was created as a practical solution to these challenges. So EESSI stands for European Environment for Scientific Software Installations. This project is a collaboration between different European HPC centers and industry partners. The goal is to build a shared stack of scientific software for HPC systems and beyond, including laptops, personal workstations, or cloud VMs. So instead of every site building and rebuilding the same software again and again, EESSI provides public repository of optimized scientific software installations. So EESSI helps to avoid duplicate work by collaborating on a shared software stack. So with EESSI, users can get access to the software in a uniform way, regardless of the system they use. EESSI designed to work on any Linux distribution and system architecture. Performance, automation, testing, and collaborations are built in from the start to ensure that a shared software is reliable, performance optimized, and ready for the modern workloads. What happened? Come on. Oh, can I go back? Yeah, OK. So this is just a graphical representation of EESSI. So EESSI can take any of your application, let's say GROMACS, LAMPS, and it automatically stream it to any HPC system. Could be on-premises cluster, cloud VM, or your personal laptop. So gated access to EASY is also developed to be flexible. So for HPC centers, EASY can be enabled through native installation of CVMFS. For users without admin privileges, EASY can be accessed through a container. Usually it's a container. And for maximum portability, EASY can be mounted in user space using CVMFS exec. So regardless of the way you install the same results, fast, consistent access to the shared software. Layered design is the core organizational principle behind EASY. So at the bottom, we have a host operating system. So EASY doesn't replace or interfere with that. It simply builds on what is already there. We have file system layer, which is based on CVMFS. CVMFS distributes software globally, caches it locally, and makes it available on demand. Then we have compatibility layer. This layer provides portable runtime environment and level the ground across different Linux distributions. And on the very top, we have software layer, where the actual scientific applications live. Yeah, I will talk about this more in the next slides. So the file system layer is what makes EASY scalable and globally accessible. So to distribute its software, EASY uses CVMFS. So CVMFS is a read-only file system widely used in large scientific infrastructures. So this layer follows the standard CVMFS architecture. So at the core, we have Stratum 0 server, where EASY software repositories are published. Then we have multiple Stratum 1 servers. They mirror the content of the Stratum 0 server. They provide redundancy, graphical distribution, and high availability. Then we have multiple local Squid proxy servers. They cache the frequently accessed data, reduce latency and external traffic. And finally, we have CVMFS clients properly configured on your machine. And the goal of these clients, they mount the CVMFS repositories and provide you access to software. So this is how it looks like. So we have CVMFS 01 server, then we have Miro servers, proxy server, and then CVMFS client configured on HPC cluster, personal laptop, or your cloud VM. To access EASY, you need to install CVMFS. So these are two commands you can use to install CVMFS on real-based distributions. Next, you need to create configuration file. So in this example, we configure the client for single user, and we set up the local cache size to be 10 gigabytes. And the last step is just to check to ensure that EASY CVMFS repository is accessible. We run sudo CVMFS config setup. So from the user perspective, EASY feels natural and easy. So when EASY is available on your system, so you need just to source EASY environment to activate it in the terminal, and then you can load module application and run it. So your software is streamed on demand, pretty much like music or TV series. So when a user loads the application, only the data that are really required are fetched. So, and when, because of the caching, only the first run downloads all the data, the next runs are faster and local. So when you activate EASY environment, EASY automatically detects the host operating system. So you can see here, Arch detect says x86 64AMD Zen 3. And then it's automatically match the software subdirectory. So you can see here, using x86 64AMD Zen 3 as software subdirectory. From here, users interact with the software using environment modules. All these modules and applications are built specifically for the, sorry. What happened? Huh? What happened? Sorry. Is it? Where is the mouse? Here? Should be here. Oh, okay. Sorry. Sorry about that. All right. Okay. Sorry. Where stop? So users interact with software through environment models, and all these models and applications are built for this specific software, or for this specific architecture. So if you, for example, model load R version 4.3.2, and then you type which R, you can see the full path. So this software is sitting under x86-64 MD, then 3. Yeah, I'll just skip this slide because I already explained that, I think. Compatibility layer is what enables a seamless experience. This layer provides what EASY calls containers without the containing. So this layer provides a minimum but complete runtime environment, including such essential tools and libraries like grips, bash, Python, almod. So this layer is built from source per CPU family using Gentoo prefix. And all software installations, including in software layer, only link to the compatibility layer using RPath. So they don't rely on system libraries. And the goal is to ensure compatibility with any client system running Linux. Software layer is where your software applications live. So this layer provides installation of scientific software applications optimized for specific CPU targets. Software built using Easy Build, but Spark is also coming. Users interact with the software using environmental models via LMOD. So your host CPU is detected using ArchSpec or ArchDetect tools. And the best subset of software installation for host CPU is automatically selected. We saw it in the previous slides. So this is how the software layer is structured. So instead of one single generic build, software is organized by architecture and microarchitecture. So for example, for x86-64 systems, you have generic, Haswell, Skylake, then 3, etc. So each of these blocks represent the set of software binaries built specific for this architecture, for this CPU target. And just a quick overview of the installed software. So currently, the public CVMFS repository contains around 900 software installations available per CPU target, and this number keeps growing. This is around 450 different software packages, excluding Python libraries, R libraries. So you can see these Espresso, GROMAX, LAMPS, the widely used applications, they're also there. In terms of performance, EASY speed ups the performance by combining architecture where builds, control runtime environment, and automated selection of the best optimized binaries. So if you see on, you can see on this graph, we have TensorFlow binary built using generic settings. On the right, we have binary optimized for Intel Haswell CPU-only system, so specifically optimized for this system. On the y-axis, you have images per second. This is the performance metric. So the more images per second, the faster the training, the better the performance. So you can see that for builds optimized for specific CPU target, you can see higher speed up, 7 times more speed up compared to the general binary. So this highlights the importance of optimizing your software to a specific architecture. Yeah, and just to conclude, what users get when they use EASY. So they substantially reduce installation time because the software is already available. Lower maintenance overhead, centralized validation and updates, improve software lifestyle management, reduce duplication effort, and they also can strengthen the inter-center collaboration. So software delivery becomes a shared and community-driven effort. Yeah, and yeah, that's pretty much me. I just want to highlight that in 2024, EASY was selected as the best HPC programming tool or technology. And yeah, you can see that's pretty much me. Thank you. Here are some resources if you want to.
Thank you, Evgeniia. Any questions from the audience?
Thank you. Very, very nice talk. About EASY,
yep.
How easy it is, no pun intended, for HPC admins to add new packages if their local users need specific things which is not in the repository and
yep.
maybe could benefit others, and yep. or if they have local stuff they'd like to have accessible through the same software stack, but they want to keep it internally for licensing reasons, for example.
So most likely the software is already available. You need to first check that. But if not, then you can talk to the EASY community and request to install this specific version of specific software. Or you can do it yourself. You can build the recipe and create pull requests and submit it to EASY repository. And this way you contribute to EASY community in a way.
Thanks.
Thank you. Any other question?
Are these modules, they have standard names? So
standard names.
I'm quite loud already.
I think you can. You mean like here?
Yeah, this one.
Yes, they usually have standard names. So you have the name of the package, in this case it's R, then you have version, and then you have toolchain, and also the year, I think. Like, this is not the best example, I think, but yeah.
The reason I'm asking is that I was wondering if somebody from your community has tried to use this system with a workflow orchestration tool such as SnakeMake and Nextflow, because we have pipelines there which can run anywhere, essentially. I think there can be a really good synergy between EASY and Nextflow and SnakeMake.
I think we have Nextflow built with EASY. So you can find Nextflow in EASY. Software stacks already.
It might be that I can install Nextflow through EASY.
Yes, exactly.
What I'm talking about is managing dependencies in Nextflow through EASY, which is slightly different.
Nextflow would load the module or would call the module.
Yeah.
In the worst case, you just need to take out a dedicated configuration that knows this module names. But it's quite standard. It will be a different naming than biocontainers or bioconda.
Yeah.
But it will be completely standardized with EASY build naming. So I'm not sure if the community Nextflow have already brought them in like in the NF4 pipelines, but if they have not, it's a quick and worthwhile job to do, because you just basically provide a config dedicated to EASY build, and it would be one for us.
Yeah, I think it would be, if it's not done yet, it would be quick and easy to, and very beneficial for the entire community. So.
Nextflow and SnakeMake are already available, so in the website.
He's asking the.
Yeah, the other way around.
Okay,
thank you. I have personally a question as well. How does it deal with different MPI flavors and so forth? I mean, is it able to once you install the module and you call it, you do a module load, is it able to use the locally installed MPI, reach out to it and understand that there's a certain communication fabric that is installed?
Yes, I believe. Not sure.
That's usually an issue with Aptena, for instance, where you don't want to use the MPI inside.
For host injections.
So EASY has this option of this concept of host injection. So that's a way to quickly customize the otherwise standard collection for anything that is specific to the particular cluster, and that is particularly true for GPUs and for MPI flavors. So you can inject that information, and then the software will be able to leverage those libraries and Fabric libraries.
Thank you.
Thank you. Yeah, of course, ideally we would want the MPI library sort of to call the implemented library that is on the host. Yeah, that's great. Thank you. Any more question? Okay, well, let's thank Evgeniia once more. I think the next talk is about so the next talk is about research software engineering using a full-stack data science approach to empower research insights by Dr. Petra Muellner.
Thank you. Yeah, thanks for the introduction, and I'm quite aware that I'm the one person between everyone and lunch, so I'll try and make this as fun and engaging as possible. So in this talk, I want to show a little bit about the work that we do at EPI. We're like a small team based in Wellington in Myanmar, and we work with open source tools and collaborate with research groups and organizations across the world and help empower research and connect it with an audience. So at EPI, we love dashboards, right? That's what we do. So we love building shiny dashboards, and my colleague Nick will also run a Birds of the Feather session on Shiny later this afternoon. So I'll stay away from the detail because Nick's the expert. I'm actually an epidemiologist, so Nick can tell you all the details, but we really love creating visual ways to engage with research and data. And so my work so my background is in epidemiology. So I'm quite fascinated by the idea, how we can connect data, analytical outputs and research, which I think, is really amazing. But bridge this gap was what organizations call operational intelligence, decision advantage, but also use this for education and awareness. And this is a little bit like this space is really, what we're trying to use, the tools we are developing. And it's, it's very obvious, you'll notice everything's getting bigger, louder, more and more. So this is becoming increasingly hard, right, to capture people's attentions, to have, like we just heard in the talk before, right, having even the computational infrastructure or data science infrastructure to manage, what needs to be done. I like to think a little bit for my work, right, because I come to this as an epidemiologist, not as a software engineer. For me, I think for technology as a tool, and the analogy I use is if we, in the past, right, if there was a disease in one village, and we needed to tell the other village, right, to be alert so the disease wouldn't spread, back in the days we just sent someone on foot, right, and then we used the horse. Eventually we had a car. We were able to send a letter, phone, email. Now we get mobile notifications. But for me, it's still the same, right? I'm trying to use something to prevent disease spread by getting information from one village to the other. And so what we're trying to strike, the whole essence of what we do is really that complex issues need collaborative thinking, right? I'm a big fan of interdisciplinary science, and so we address this through highly bespoke solutions and are trying to combine subject matter expertise with technology like software engineering, data science, and also user interface and user experience design. And so what we often see in our work, that we may have solutions where the subject matter expertise drives the project, right? So you've got people who are super passionate, know things in and out. But you may still then end up with overly detailed, applications or interfaces that can be kind of really off-putting, for someone who's not so knee-deep into it. They may struggle to scale these, right? So they, we often see this is a bit of a breaking point where people come for help, where it gets frustrated because, it gets slower and slower and slower. And there's security risks, that need to be addressed. At the same time, if we have things that are very technology-driven, sometimes scientific conventions are ignored, and scientists do not like that. Or there could be a low engagement and a poor user experience. And I think it's a really a fine balance, right, where kind of deep collaboration needs to happen to really create these interfaces that connect with people. And because no one needs more of this, right? Everyone's overwhelmed. We need things that connects with us easily, and that's not complicated to use. And I think if we get it right, the opportunities are truly endless, right? We can really generate operational intelligence and decision support. It actually works out there in practice. We can use these tools for stakeholder training, awareness, and engagement. Support routine reporting, which is quite important. For example, I work a lot with disease surveillance data, and there's like international standards or diagnostic standards. So this routine structured reporting is really critical for policies and decision support. We can then take it all for a spin and integrate complex model, make complex data usable and shareable, and also support global efforts across language barriers and create digital public goods. But there is a lot of risk and challenges that need specialist expertise to get this right. And so I just want to take you on a little bit of a tour how, at EP in collaboration, with the great people we get to work with, put all this together, and so it's not just a theory, but it's actually how we make this happen in practice. And I just want to show you, I've got like 4 tools I want to introduce you to. 2 of those we're going to quickly live demo with the help from Nick here in the back shortly. But just to introduce you to the first 2, we've got like a disease modeling app that we've developed, I think 7 or 8 years ago we started working on this. So what it does, it takes infectious disease models and creates an interface for them, so people can look at it and say like, oh, what happens if I vaccinate? What happens if the vaccination rate differ? What happens if I use another model? How does this look for, avian influenza or COVID or African swine fever? So, for those of you who work with models, they're really complex. If you read a textbook about infectious disease modeling from page 3, most people get lost. So this is lots of context-sensitive information, training involved, and is used actually quite widely for field epidemiology training. I just got an email from the European Center for Disease Control who use it, for some of the outbreak training, and so it's a kind of really cool success story for how an academic tool, can then be used globally and help link that crucial science to policy link. So this has been a long, multi-year collaboration with the Royal Veterinary College initially, and then the City University of Hong Kong. And then the second tool I want to just quickly dive into is a dashboard we've just quickly developed for Australia's marine parks. This work is funded and led by the Minderoo Foundation Oceanomics team, so we were very grateful to have worked with them. And I just want to show you how when you have a huge data set, so this is like an environmental DNA data set, so there is like, as you can see here, there's like over 250,000 marine vertebrate eDNA observations in the data set, right? And I want to show you this as an example of how we can create accessibility for complex data. And also, we have like a data set that's been a huge research investment, by multiple parties, and how to kind of like help make that accessible as well. So without further ado, so I'm just going to quickly show you these 2 apps. So you can see they actually exist. And they're both freely available if you want to see them. So. Okay, here it comes. So this is the infectious disease modeling app Epidemics. Like as you can see, we've actually have a plus, and how it says a plus in base. So we've got a plus in base version, just because sometimes the app gets used, in large cohort training, a couple of 100 students in undergraduate programs. And it's just more cost efficient to have a bit of a slimmed down version of the app to run this. But I think I just want to illustrate here like the educational component of the app. So we can start off with take a tour. So you can actually see how, there's lots of user guidance embedded in the interface, right? So there's like self-learning, so you can click through that. It explains all the parameters. And then, Nick, if you want to close that, what we also have here is a ton of info buttons. You know, when you, for example, select the infection states to consider, you get a really detailed explanation of what works, right? So it's kind of really not off-putting, but really engaging for people to, people who work out in the field trying to understand what it works. So if you just look, there's plenty of disease models in there. So Nick, if you just click on the drop down, you can see there's all to the extent of having network models. So if you want to click on that, then you can see the network ones. Thank you. Submit, and then you can. Yeah, and you can look at Explore, exactly, that's the one. So you can see there's different visualizations, and you can also visualize the spread of the infections through a network. So lots going on there. We also have disease-specific models in there, and in those disease-specific models, these are a little bit more applied. So for example, here we can use the African swine fever. We have the influenza ones as well. But what you can see on those, they have those scenario exercises, which are used in field training, right? So this is almost like where the dashboard shifts to online learning, and people can work through the applied exercise. And this applied exercise is actually, you can see the button here has a multilingual functionality, right? And so we crowdsource translations for this, so we've got a template, and people kindly donated their time. So it's kind of pretty cool. So you can see it's very universal, very global, really getting that critical knowledge for disease control across. And I could talk about this app all day, but I think we'll just quickly switch to the other case study I just want to quickly dive into, which is the Marine Parks dashboard. So this is the environmental DNA data set. So this is a completely different thing, right? It kind of creates connections of this super mega data set, and then takes the user through it. There's different ways they can explore it by location, by specific marine park, by species. They can chat with the data. So there's an LMN integration in there, and also explore a little bit the unknown. And then again, educational again, with key statistics. And at the very end, we also present case studies, where people can then also explore the data. And if you just quickly click on the explore the species, click, and then and you can just, for example, so there's this agreement of terms and conditions, and then we can, for example, here have a look, pick at some favorites and look at the high profile searches, and we have, for example, some coral reef icons on there, what I mean, they then get strolled through the data set and show what it's done. So this sits obviously in a huge body of research. It's led by the researchers. Our role is to support it, magnify it, link it with an audience, right? So you can see this and then explore the data. You can animate it. So there's all sorts of map features and things in there as well. Anyway, so you can explore this free. It's freely available for everyone. We have links on our website if you want to find it. And then, Nick, if you bring me back to my the presentation. Yeah, awesome. Thank you. Yeah, so this is just, I just want to say that it's not theory. This is actually for real. And then other examples, so this is also from a research perspective, for long-term collaborations we have with the University of Minnesota in the US. So they develop very complex risk models around biosecurity incursions in the lakes in Minnesota. For those of you who've been there, they've got on the north of Minnesota, there's over 10,000 lakes that are threatened by aquatic invasive species. So they got risk models using game theory, predicting incursion risk. And so this is a really good example of how we go from research to operational intelligence to practical biosecurity decision making. So this app is actually used by the biosecurity ground staff there to help inform where they put inspector stations for biosecurity and things like that. So I think it's been going for like 5 years plus. I think we're at this point now with the collaboration, and the app has just grown. Research grant by research grant, as you do. And then this is another global project they do with PERBRIDE, the European Commission for the Control of Foot and Mouth Disease, who provided funding. And this works with the World Reference Lab for Foot and Mouth Disease virus. I think everyone here in New Zealand is familiar. It's like the major global livestock disease. And so we also use this global data set that comes from all the world reference laboratories from FAO and the World Organization for Animal Health, and then have different tools to map the data. There's genotyping reports where you can upload sequences, so work quite closely with PERBRIDE's bioinformatics team on this, and also have decision support tools around vaccine selection. Anyway, and then we also do the antimicrobial resistance and consumption dashboards for the World Health Organization, which is the last example I wanted to show you because it highlights what I said before around the standard reporting, right, on global health issues that is important, and I think where these dashboards play a key role. Anyway, so final messages, I think, you know, it's hard to do these things. These are all deeply interdisciplinary projects, right? And our work sits on a base of multi-year research, right? We're just lucky to have the opportunity to help connect it. It is really a lot about the people, and, you know, this just shows us with a couple of our collaborators, the Minnesota team, and then Antonella from PERBRIDE on his visit to New Zealand recently. And, you know, as I said, you know, we're just very lucky, right? We get to work with lots of great people and then, you know, apply our tools and our expertise. So huge amount of researchers that all played a key role, and, you know, without their work and the models they developed, the data collection, you know, all this work wouldn't be possible, right? So I really like to acknowledge and thank all of them for, you know, working with us. And yeah, I just want to say thank you. If you want to stay in touch with us, we do have a newsletter. We have all these work examples on the website, right? If you're looking for inspiration and just see, you know, what's possible. So we make those available. You know, we also run a big open source data science event, iExchange, in the National Library in Wellington, you know, which might be interesting. I think some people who are here are actually attending. So yeah, thanks very much for your time.
Thank you, Petra. I think that's a really nice presentation, and shows, you know, the importance of communication and how to engage with lay people and other scientists as well. There is time for questions. Maxime.
Thanks. Very nice presentation. Beautiful dashboards. They seem very neat and very well crafted. My question is, how do you control for the cost? And I suppose they're hosted somewhere in servers, or if you're using RShiny. And so how do you make sure that, you know, if there's an army of AI bots that wants to click on all buttons, the bill at the end of the month is still reasonable for your stakeholders?
So, you know, because we work with open source, right? There's not a product or a certain way we do things, right? So every organizations we work with, we work in different ways. So we've got our own high-performing, you know, infrastructure and hosting environment, which some of these apps are hosted on. You know, other apps are actually hosted by the organizations we work with because they already have internal capability, and we just help them set it up. And like, as you said, a lot goes to it, right? And I think one thing that's really important is that we, you know, these dashboards are like cars, right? They need maintenance, right? It's not like something you build on off. So a role that we often take in these projects is also, you know, develop the tools, or, you know, help, you know, create that window into the research, but we also take the responsibility for hosting these dashboards for multiple years, you know, on conclusion. Also, there's this continuity, you know, of support for the dashboard. It has like a home, you know, home to live in. And I think there's an increasing understanding also for funders or everyone that, like as I said, it is a kite, needs maintenance. It's not something you produce and then you let rot away, right? So, yeah.
I think there is time maybe for a quick question, if somebody has. I would have a question otherwise. I guess, how do you know, presumably, you know, probably one of the challenges is is you have these dashboards and so forth, and which ones actually work best. You know, which ones do you get any feedback from the users or the general population or whoever actually goes to your websites, and can you gather or harvest some information so that next round you can do things even better?
That's a really good question. So I think we often, in our project, right, we don't just go ahead, jump in and build a dashboard. We have like a proven process, right, where we go through an analysis and design phase, where we work with the groups we work with, and we develop some designs, which are mock-ups, right? They're design mock-ups. And so we test those with the audience, right, and say, like, what do you think of this? We get stakeholder feedback before we even write a single line of code. Because I think it's a really important point, because it's, people don't want we don't build a dashboard we think people need. We're trying to build a dashboard people actually, want and enjoy. And it's kind of it can be quite rewarding process, because you really, through these conversations, you really get an understanding of, what makes people click, what I mean, what they enjoy about the dashboard. And sometimes it's just the small things that are a problem, and it can, it's a few little things that people find annoying, right? And if you address these, you can actually increase engagement, with little effort, yeah.
Well, let's thank again Petra and all the previous speakers as well.